We are live now. I hope that you are hearing me just clearly. Hello, everybody. On 279th WJUG meetup. We are very happy to host today Josh Long from Spring, from VMware. He's a Spring developer advocate since 2010, so he really knows what he's talking about when it comes to Spring. And today he will cover the Reactive Spring. I will do this presentation as short as possible. So as always, I'll just want to thank our regular partners, Statia IT, JetBrains, Decerto, and Software Mill. We'll be having prizes for you. From JetBrains, we have JetBrains licenses, and from the Decerto, we are having books and programmatic topics, and Statia IT also does one-day workshop free entrance for you guys. So listen carefully, pay attention to Josh Long's presentation, because there will be a question just about the presentation. And we'll be having a short contest just after the presentation for everybody. And as always, please say on the chat that everything's fine, that you're hearing us clearly, that you are seeing us clearly. And as WJUG, we are always happy when you're giving us our feedback. Today we'll not having a sort of survey as we always regularly does, but if you want to contact us, just choose something from that medium, and we'll be happy to answer you on any of that. So as I mentioned, I want to be as short with this presentation as possible. So Josh, thank you very, very much for actually coming to us and reaching out to us with your presentation. And thank you very much one more time. One more thing, the Q&A, please ask your question about the presentation on the YouTube channel or on the YouTube chat, and we'll ask them to Josh after the whole presentation. So the Q&A session will be just after the whole presentation. And that's everything from my side. And our virtual Warsaw Java user group stage is all yours, Josh. Thank you.
All right, thank you. Okay, good stuff. Okay, my friends, I appreciate you all being here. Thank you so much. Couple things. First of all, I have a bit of a cold, so I might be sneezing when we're presenting. Sorry about that. Good news, at least we're not in the same room, so I can't open source my code. That's nice. And after we're done, I can just crawl right back into bed. So this is actually a silver lining. There's not much to like about this year, but the fact that you don't have to get my cold, wonderful. I appreciate the opportunity to be with you all today. I wish I could be there in person, healthy, of course, but I wish I could be there in person. I haven't been there for a couple of years. I don't know when the last time I spoke at this user group was, but I remember I had a wonderful time the times I did speak there. I am Josh Long. I work on the Spring team. I'm a Spring developer advocate. I'm a Kotlin Google developer expert and a Java champion. And I'm at your service. I have Twitter. If you're on Twitter, you can find me on Twitter. You can send me messages there or via email. Either way, I'm happy to respond, happy to engage. We're going to be talking about reactive programming and building cloud-native applications today. And so we've got a lot of stuff to cover. We have a lot of stuff to cover. I think we've got 90 minutes or so, something like that. So not a lot of time, and we do have a lot to get through. So as always, I encourage you to take note of that Git repository. That repository contains everything we're going to look at today, basically. So a lot of good stuff there. Now, I work on the Spring team, as was just well explained. I have done training videos. I've done training videos. These are on Safari. I've done a book a few years ago called Cloud Native Java. I have a podcast every Friday where I have a new interview with somebody amazing, somebody who teaches me something. That's every Friday, usually. Although, to be fair, I just released 2 episodes yesterday because of a mistake I made last week. So yesterday was special. Yesterday was two episodes on a day that was not Friday. And then, of course, there's This Week in Spring, which is a blog I do every Tuesday, where it's just a roundup of all the interesting stuff in the ecosystem. And of course, I have a screencast called Spring Tips, which is just me looking at some corners of the ecosystem, looking at the details of one particular technology in the Spring ecosystem. And of course, I have my new book called Reactive Spring. And Reactive Spring is a look at how to use reactive programming. And we're going to use reactive programming a lot today. Now, first of all, before we get too far into reactive programming, we need to consider why we care about this, right? What is the motivation? What's the business context that forces us to care about this? Now, you can see I've got no slide advancer and my screen is empty, so we're just talking here, okay? Don't worry, the screen is not frozen. We're just talking. So let's consider the big picture. Why do we care about reactive programming? What is it that motivates us to use reactive programming, to care about this? And I would say that, like so many things today, the thing that makes it so useful for us is our movement to production. And today, that production environment is the cloud. Now, consider what I mean by that. Well, most organizations are starting to understand that it's important that we get to production quickly. They know that we need to get to production quickly. And the reason they know that is because the faster they go to production, the faster they can validate that what they have done is worth doing, and the faster they can then start again, right? So that cycle time from concept to customer and then back again is very, very important. And the faster we can do that, the more we learn. So really what we're all trying to do here is to learn quickly. Learning is key, right? So we want processes that allow us to optimize how quickly we learn. We want to become learning organizations. And so if you keep this as your motivation, if you think about that as the number one thing that is the background for everything else you do, the backdrop for everything else you do, well, a lot of things come from that naturally. First and foremost, learning is very important because we want to improve, right? So what things fall out of that? What things are naturally going to happen as a result of that movement? Well, I want to improve the speed of my testing. So I do test-driven development, and then I do continuous integration. I want to improve the speed of my deployment to production. So I use cloud computing. I want to improve the speed of my observability. I want to learn more from my observability. So I learn about things like observability and canary builds and so on. I want to improve the speed at which I write new features. So I take advantage of agile programming, etc. So there's all these different things that if we take them together, really the main thing they give us is speed, so that we can learn more quickly. Super important, right? One thing that we can do that helps us as an organization is to look at the development group itself. Look at the people who are working on a code base. Looking at product management, user experience, developers, testers, administrators, all these people who work on a code base have to coordinate, they have to synchronize. And that coordination cost is a problem because it means that a lot of people have to be on the same page. And this means meetings and stand-up calls and 2 or 3 stand-up calls in the morning for different time zones and all sorts of different things like this, maybe in the afternoon, right? So this is a problem because it means that everything is very slow. So what we can do is we can take these large teams and break them into smaller teams, much smaller teams. But these smaller teams, if they're all in a single place and they all have the ability to very quickly cycle, they can get a lot done. The only problem is that now they have a smaller scope, right? Because less people, less scope. So you have to divide the code base into smaller chunks. And this gives us some very interesting benefits. By dividing our code base into smaller pieces, we have less work for people to do. We can focus on one thing. What is the one thing that we focus on? Well, Eric Evans, in his book, Domain-Driven Design, talks about a bounded context. A bounded context is a part of the domain model that stands by itself without any other dependencies. If you can identify bounded contexts, then we have a natural place to make these divisions. And that's a good result because now you can have something that is internally consistent without any other dependencies, that can stand by itself. These bounded contexts are a very natural place to divide our code bases. And we can now deploy these code bases independent of other parts of the code base, right? We don't need other teams involved when we deploy our code base. What I'm describing here, a small, singly focused, independently deployable, reusable, bounded context, that's a microservice. A microservice is a way to get small teams so that we can reduce the cost of synchronization so that we can get to production faster. Microservices are a technology fix for an organizational problem. You understand? And this is not a new idea. This is not a new concept. Mel Conway in the 1970s, he understood that software is a mirror image of the communication patterns of the organization that built it. So if your organization is dysfunctional, your software will be dysfunctional as well. And so in order to fix that, you fix the organization, and then the software gets better. Excuse me. So that's what we're doing here, is we're improving our software. We're improving our organization by improving our software. We're improving our software by improving our organization. This is a reverse Conway maneuver. It's a bit of a hack where we optimize one thing to get the other to work. Now, what happens when you do this? What happens when you move to microservices? What happens when you start deploying small, independently deployed, reusable bounded contexts? Well, obviously, we get some new technical issues, right? Nothing is free. Everything has a cost. What costs come from lots of small services that are deployed over the network? Well, you get volatility, right? You get latency. You get worries about the performance and resource efficiency. And so here, what we need is a programming model that allows us to address these different kinds of concerns, to allow us to describe services in a way that are going to work in a production environment where we have lots of network I/O. And this is where reactive programming comes in. Reactive programming gives us a way to address three main concerns, three big issues, three big points: resource efficiency, reliability, and failure tolerance, right? So, and consistency, failure tolerance, and resource efficiency. So failure tolerance, consistency, resource efficiency, right? These three things are super important. Let's break them down, right? First thing is resource efficiency. This is a problem today, right? Today in 2020. By the end of 2021, it'll be less of a problem, but it'll still be a problem. And what I mean by that is when we do input and output on the network, today on Java, on the JVM, that input and output, that asynchronous I/O, that synchronous I/O is blocking for most code, right? For a lot of code out there in production, that input and output over the network uses Java I/O input stream and output stream. Java I/O input stream and output stream are blocking APIs. And what I mean by that is when you call input stream.read and you read the next byte or the next bytes from an input stream, you're sitting on a thread that cannot be reused. That thread is stuck waiting for the next byte. You say input stream.read, and then you just wait. What are you going to do? You can't go anywhere. You can't move forward. Nobody else can reuse that thread. That thread is very expensive today in 2020. It costs a lot of resources to create a thread in the JVM. Obviously, hopefully, Project Loom will fix that, right? Project Loom will make it so that we can create lots of threads very cheaply. But even there, sorry, I gotta sneeze. Even there, we won't be able to get all the benefits that we want, right? Because even though the threads are cheap now, or there will be in the future, even though the threads will be cheap then, our ability to use input streams and output streams will still be limited because we have these buffers inside of all the different input streams and output streams, right? So each buffer, if you create a thread and you have an input stream, each buffered input stream has a buffer of like a kilobyte, right? So imagine creating a million of these or several million of these. It's going to be very expensive. You're going to run out of RAM before you run out of threads, right? So either way, there's a bottleneck there, and it becomes very useful to learn how to reuse our threads, how to make better reuse of the threads instead of just creating new ones. So that's the first thing. Second thing is we want a programming model that allows us to think about the world as being different sources and sinks, different streams of data, different things that do different things, that give us different kinds of data that we can integrate in a consistent fashion. Because remember, my data might live over here in a database, it might live over here in a microservice, it might be HTTP, it might be RSocket, it might be WebSocket, whatever, right? It might be gRPC. So we have to make sure that we do that we have a programming model that allows us to integrate different sources and sinks of data. And that's where reactive programming comes in. It's a consistent way to describe data that is potentially latent, that is to say it's slow or might take a while. It is potentially unbounded, that is to say it might be infinite, and it's potentially going to fail, right? It might fail, it might not happen. And so we need a programming model that makes it easier for us to describe all these things in a unified fashion. This makes it easier to compose our sources and our sinks, our data streams. And that makes life easier because you get one kind of stuff, one kind of API. So that's the second thing we want, is a consistent, uniform interface. And the third thing that we want is a toolbox to describe and to work with something that is inherently volatile, something that will probably fail, right? The internet is, it's going to fail. Things fail all the time. The network fails all the time. So we have to write software where we do the right thing in the face of that outage and that service topology change. So today, my friends, we're going to talk about all of that. We're going to talk about all these different tools and techniques that we can use to write software that's better destined for production. And we're going to do so by looking at reactive programming and all the support in the Spring ecosystem for building cloud-native applications. Ooh. Sorry, didn't want the heater. So in order to do that, let's go to my second favorite place on the internet. Obviously, my first favorite place on the internet is production. So what we're going to do is we're going to build an application called Customers. And we're going to use Spring Boot 2.4.1. That's brand new. So we might have to build dependencies before we actually import it into the IDE. Okay, so we're going to build a brand new application using Spring Boot 2.4.1. We have to choose a packaging. Obviously, jar is the default, and that's a good idea. Leave it there. That's part of my overarching and guiding personal philosophy of make jar, not war. And then we have, of course, the choice of which version of Java we want to use. And my friends, we have 3 choices down here, but really only 2 actual choices. Java 15 is the current supported version of Java, and Java 11 is the current long-term supported version of Java. Both of these are acceptable today. Java 8 is a non-choice. And non-choice is not just an Indian bread, my friends. It's a choice that you could make, but that you should not make. It's a choice that represents the worst of all these options. It is technically inferior in every way. It is slower, less feature-rich, less syntax-rich, less performant, less robust, less secure, etc. It's also morally inferior. My friends, you're not going to like the look of disgust and despair on your children's faces when they realize you're using Java 8 in production. Don't do it. Be the change you want to see. Use Java 11 or 15. Do the right thing. Now, I'm happy with Java 15 or Java 11. I'm going to leave it with Java 11. And then we have to bring in some dependencies. So we want to bring in the reactive web support. We want to bring in Lombok. We want to bring in a reactive database, right? So R2BBC, H2, and we want to bring in a few other dependencies as well. Spring Cloud Config Client, the Eureka Discovery Client, the RabbitMQ dependency, so Spring for RabbitMQ, the Spring Cloud Stream dependency as well, and the actuator, okay? There we go. So there's a number of different endpoints that allow us to describe what we're trying to do. So let's go ahead and import this dependency into our database, into our IDE. So I'll generate it, downloads. All right, so here we are. Now, like I said, new version. Let's make sure we do a Maven install there. Oh, come on, faster. Sorry about this. Okay, we're good. Okay, so resolving dependencies. And the first thing that we're going to do, now that we have this new project open, is we're going to disable certain dependencies. So let's go back to pom.xml and comment out the bits that we don't need just yet. So Spring Boot Starter AMQP, don't need that yet. The config client, don't need this. Let's just start here, go down to this here. All right, so we've commented out everything except for the actuator, the R2BC dependency, the reactive web support, the H2 dependency, which we don't need there, and the R2 H dependency, which R2BC H2 dependency. So R2BC is a reactive relational database connectivity abstraction. It supports reactive SQL-based data access. There are, there's R2BC implementations for everything. There's Oracle, Microsoft SQL Server, Postgres, MariaDB, MySQL, H2, SAP HANA, lots of stuff, right? Like I'm sure I'm missing some, but there's a bunch, right? And so there's a lot of different R2BC implementations. These are not based on JDBC. JDBC is a blocking synchronous API. So it's easier instead to use R2DBC in a reactive application. R2DBC, like I said, there's different implementations. They behind the scenes, they support asynchronous I/O. That's the important part there, right? Is they're using an abstraction that allows them to say, I want to send these bytes and I want to read these bytes, but when these bytes are not here, I will jump off of the thread. I will let somebody else reuse that thread. And that's very important because now the scheduler, the runtime, can make it easier for the system to repurpose the thread for other work, okay? So now let's go to customers, and we're going to create a new application. And this application is going to store data in a database. So I'm going to say class customer. And this customer object is going to have a field called an ID and another field called name. And this object will have data at all args constructor, no args constructor. Okay. Good. So there's this. Now, there's our basic description of the object. We're going to create an ID field here. And that's the basic structure. Now, obviously, in Java 14 and later, as a preview feature, there's a nice feature called record. So record customer string name integer ID. That would have been nice. In Scala, we have case classes like this, customer name string ID int, right? Like that. And the same is true for Kotlin, right? In Kotlin, you have the same basic structure. So all of these are nice compared to what I've just done here. Hopefully, the preview feature will eventually become a GA feature, and then we can just write this code instead and get getters, setters, toString equals hash code, all that stuff. Then we need some way to write this to the database. So I'm going to create a repository, and this repository is going to handle the boring work of reading and writing and updating data into the database. So it's going to be a repository that manages data with an entity of type customer whose primary key is of type integer. And the repository, well, this is interesting. Ready? We're going to try this. Well, what's the difference? Whoa, that is cool. That is neat. Okay, well, so we have a repository, and this repository handles the normal stuff like reading and writing and updating and deleting. So we have methods here that support things like save, save all, count, delete, find by ID, etc. All of that is fairly straightforward. What you may not be familiar with are these types, these parameter types. The first is a publisher. The publisher comes from the org reactive streams package. The publisher, it publishes data asynchronously out of band to a subscriber. The subscriber, when it first subscribes, it is given a subscription. We're going to come back to that in just a second. That's very important. Then, as each new record is available, it is passed here in the onNext method. When there are errors, they are passed here on the onError method. And when we are done processing the data, that's passed here in the onComplete method. So the subscriber subscribes to data from the publisher. Okay. Now I said that the subscriber is given a subscription. This subscription is the most important part. This subscription is what the subscriber uses to ask for more or less data. The subscriber, when it asks for more data, it can call request. It can say, I want to request 10 more records or 100 more records or 1,000 more records. If it requests -1, that means send everything that you have, not just 1 or 2 records, but everything. Okay. And then if you want to cancel the production of the data, you can call subscription.cancel. Either way, these are Okay. Either way, these are the subscription is what we use to request more or less data. It's very important, right? Because now the subscriber can say, hey, I want 10 more records, and I don't want anything more than 10 records. It's very, very important because now the subscriber controls the rate at which it consumes the data. We all understand this at the small level, right? When you write a low-level network protocol using TCP or UDP, we understand that we have to think about flow control. What happens when one socket sends more bytes than the other one can handle at a given time? You always have to think about the state machine required to enable flow control, to push back when there's too much data. That's built in the complexity of building network protocols. That's one of the hardest parts, right? This is why libraries like Netty exist, specifically to make it easier to have things like message framing and flow control in all your protocols. So we have to think about that, right? We have to think about that low-level thing. That's easy, right? That's pretty easy. We have a thing to request more or less data, and we control the rate of consumption. Okay, what about at the large scale? Well, if you've ever built a distributed system, then you think about messaging, right? Messaging is a very natural way for one service to work with another. Messaging achieves the same thing. The producer sends data to the message broker, and the broker serializes the data, and the consumer consumes the data one message at a time as fast as it can, but no faster. This way, if there's too much load, if there's too much demand, it gets slowed down by the broker. The broker absorbs the extra messages. And then when the consumer is ready to handle them, then and only then does it handle it, right? So that way, even if there's a lot of load, it just gets stored in the broker. This is called a store and forward architecture. And it also helps with flow control. So big distributed systems, flow control. Small network protocol, flow control. So all we're doing here is at the Java API, we're giving you explicit control over flow control. This is sometimes called back pressure. And it's the ability of the consumer, the thing that's going to be processing the data, to push back against the producer to say, I cannot handle anymore, slow down, right? This is very useful in building more reliable, more robust services. Sorry. I gotta commit something here. Okay. So flow control, very useful in the subscriber. Now, these are three types. There's a fourth type called a processor. This processor is a bridge. It's a source and a sink. It's a producer and a consumer, a publisher and a subscriber. This processor is the thing that allows us to send and consume from the same named memory chunk, right? Now we have these four types that we can agree they're very basic, very foundational. They're so foundational that they're actually now part of the JDK. So if you go to Java util concurrent flow is the class, outer class, and then you've got wow, this is cool. Then you have the inner types. So flow.publisher, flow.subscriber, flow.subscription, and flow.processor. These are the exact same things as the Reactive Streams type. So they're in the JDK as of Java 9. So Java 9 or Java 8, if you use the Reactive Stream specification, you can even adapt one from the other. You can say, I want to convert a Java util concurrent flow to a Reactive Streams type, or vice versa. I can do a flow publisher from a Reactive Streams publisher. So either way, you have this very easy ability to convert one from the other. That's the power here, right? That's the real awesome opportunity, is that these things are now interchangeable. But they're still pretty basic, right? They're still foundational. And so what we need are operators to make life easier, to support filtering, mapping, flat mapping, and composition, and so on. And so for this, we have these two specialized types that comes from Project Reactor. Project Reactor is a data flow library built by the Spring team. You don't need Spring to use Project Reactor, but you do need Project Reactor to use the reactive web support in Spring. So the Flux is the first reactive type. It's a publisher that produces 0 or more records, 0, 1, 2, 5, a billion, a trillion, or infinite records. But it also has lots and lots of operators. Look at all that code, lots of operators, right? There's also Mono. Mono is a publisher that produces 0 or 1 record. So at most 1, never more than 1. It's like a completable future, except it supports back pressure. So lots of operators there too, right? So these two types, very useful. They give us semantics. So if somebody says, here's a publisher of customer, what are you supposed to do with that? Are you supposed to render the details for 1 record? Or are you supposed to render all of the records from like a search result or something? Well, if somebody gives you a mono of customer, now you know it's one detailed record, maybe, right? And if they give you a flex of publisher, of customer, then now you have, maybe it's the search results from multiple records, that kind of thing. So we have a repository, and what I want to do is I want to write some of that data to the database. So I'll create a bean here, an application listener, application ready event, ready application listener. And this is just a callback interface in Spring, and I'm going to use it to inject my customer repository, and I'll use that to write some data to the database. So we'll say, okay, let's get some names of people who are on the Spring team. But before I can write that data to the database, I need to create the table, because remember, we're using H2. H2 is a in-memory embeddable, SQL database. So it'll lose all of its data on every single restart. Okay, so we're going to say dbc.sql, and we're going to create our table. So we'll say create table, customer ID serial primary key not null, and then name varchar 255 not null. Okay, so this is my table, and then we're going to say, okay, fetch. We want to execute that, right? So fetch, and we want to get the rows updated. That'll give us a reactive stream of type mono of integer. So that's the first thing we want to do, right? Step one. And then step two, I want to create a reactive stream of names that we can write to the database. So I'll say publisher.just or flex.just. My name is Josh. Nice to meet you. There's a lot of other amazing people in the Spring team as well. So we've got the Marcin, of course. We've got the Olga, of course. We've got Madura. We've got Violetta. We've got Stefan, Dr. Sawyer. So what is that? That's 2, 4, 6, 7. We need an 8th name. Yushin. There we go. So there's our 8 names. And I want to take each one of these names and turn it into a customer. So I'll visit each one of those. I'll say map name into a new customer. So, and I want to visit each one of these and then write it to the database. So customer, and I'll use the repository that we injected, cr.save. Okay. And the reason I'm doing flat map is because the return value of save is a publisher of customer. Okay. So if I don't do flat map, then what happens is we have 2 reactive types, map, and we get this. We get publisher of mono of customer, right? We don't want that. We want just one nested reactive type, right? So there you go. There's our flat map. We have to flatten the inner stream, just like the curve. We flatten it, right? So here we go. Replace it with a method reference. Very good. So there's this. Now there's our reactive stream. That's our data. What else do we want to do? Well, I want to find all the results. I want to say, okay, cr.findAll. And that'll give me a stream there. So now I've got step 3, right? I've done 3 different things. Now, the thing is, nothing is going to happen unless I call .subscribe, right? If you call subscribe, that's what triggers the execution there. Excuse me. So, integer.subscribe. Okay. So we say integer.subscribe, integer monitor.subscribe, and that gives us the ability to kick off the execution of the pipeline. The subscribe operation is what starts the pipeline. So we have a pipeline here. This is like how the pipes will connect. Water will flow through these pipes, but we haven't actually described how these pipes will, how the water, we've described how the water will flow, but we haven't actually turned on the faucet, right? So in order to turn on the faucet, you must call subscribe. The only problem is that if you call subscribe here, this will execute on a different thread. There's no guarantee that that will execute on the same thread as this one, or that will execute on the same thread as this one. It's asynchronous. And so we cannot be guaranteed that this will finish before this starts, and we can't be guaranteed that that will finish before this starts. So we want to combine them together. And so thankfully we can do this. We can say integer mono dot then many names dot then many all. And now we can subscribe to the whole thing. And the result will be that it'll execute all three in the right order. We guarantee that one thing will follow after another. That's different, right? So we can also print out what's happening. Right, system out, print line. Okay, there we go. Good. So we have our reactive stream. Now, obviously, this is a lot of code, right? I can simplify this. I wouldn't write this code like this. Most of the time, you'd probably just compose these things together in a stream. Once you get used to it, it's very natural to do that, right? So, for example, and then that goes there. Okay. Easier, right? Now we have our reactive stream. We have the data in the database. Let's go ahead and run the code and see what happens. Run. Okay, there we go. There's our data. There's our 8 records in the database. It's working. Of course, it's working. It was a demo. What were you expecting? Now, at this point, we can consider how to get to production, right? We can think about how we take our code, which is now built the way we want it to be built, and deploy it to production. And there's several things that we care about when we go to production. First and foremost, I care about observability. I care about integrating with my production observability stack. So obviously, we have the Spring Boot actuator. The Spring Boot actuator add a set of standardized endpoints that give you information about the service itself. Remember, there's only so much that you will be able to see from the low-level container or orchestrator, right? The container orchestrator will not have a good picture of what your application is doing. It's up to your service to tell the world how your application is doing. And so the Spring Boot actuator gives you endpoints that service that use case, right? So I can go to application.properties. Web. So we want to say actuator, management, there we go. Web include, okay, all of them. And then we want the probes, we want to enable the probes. There we go. So I'm going to include all the actuator endpoints to expose them by default. And then I'll enable the 2 Kubernetes probes, okay? And once I've done that, I'm going to restart the application. And we should see that information is now available. So let's go ahead and restart here. Here we go. Whoop. Hello. Localhost actuator health. Okay. Whoops. 8080. There's my data, right? So I've got now a working web endpoint. And this information is going to be very useful, as we'll see in just a second. But since we've got a web endpoint, I also want to have a web service. I want to create a web endpoint with my web server, right? So I'm going to go ahead and turn this into just that. And I'll create a simple reactive web endpoint. I can do this using a REST controller style. I can say at REST controller, as customer REST controller. Or I could use the functional reactive style, but I like this style a lot. This works as well. They're both great. So this is a functional, this is a reactive rather endpoint. I'm going to inject the argument that I need there in the constructor. I'll create this endpoint, get mapping, customers, publisher of customer, get. Turn this dot find all. Okay, good. So this is my reactive stream. Oh, that's cool. That's new. That's new. That's very cool. Do you see that little icon there? Show available actions for URL. That must be in the new release. Okay. So let's go ahead and restart this. Oh, perfect. Okay. Good. 1.4. Good. The application's up and running. So now if we go here to customers, Good, data's there. Go back to the actuator. We've got several endpoints here that give us information about the state of the application. We get information about the beans, the different caches, the health endpoint, information about the application, the environment, loggers, all this kind of stuff that you can use. There's also the metrics endpoint. And this, of course, is just the default list of metrics that we have available. You can use project micrometer. So micrometer.io will automatically, it's a metrics facade API, and you can use it to talk to different metrics services, or time series databases, things like Prometheus, which is very common in Kubernetes, right? Or Wavefront, or New Relic, or Datadog, or Dynatrace, or whatever, right? Actually, a few of these companies have gone public. They're so successful. So there's a lot of good options out there that you can use. Spring speaks to all of them. You can automatically export these metrics and your own custom metrics to any of these time series database providers. Now, I've also got the health endpoint. The health endpoint gives me information about how healthy my service is. If any of my subsystems have failed, if my database connection or my message queue connection or whatever have failed, then this will show fail. Now, I've got some probes here as well. These are Kubernetes liveness and readiness probes. The readiness probe tells Kubernetes whether the service is ready to start being put into production, into load balancing, right? So the readiness probe is what tells the cluster whether this service is ready to start serving traffic. The liveness probe, on the other hand, tells the cluster whether the service is ready to, is whether it's still alive or not, right? So liveness. Either way, these are very useful in a Kubernetes environment. They're sort of specialized versions of the health endpoint. You don't have to enable them, of course, but they're useful in this case, so I enabled them. Now, once I've got these, what happens if my application is sick, right? Well, I can manually rather decide whether to make a service sick or not, right? I can actually say, okay, REST controller class, liveness REST controller, okay, and it'll be post mapping down. I'm going to do mono of void down mono.empty. Okay, so there's this. And what I'm going to do is when somebody calls this endpoint, I want to trigger the liveness probe to go down. So I'll say application context, required args constructor, and I'll just publish an event. I'll say availability change event dot publish this dot application context, and I'm going to send a liveness state dot broken, like so. Okay, there's my published event there, my published result. I'm going to trigger that this endpoint should go down. Let's go ahead and restart. And I can trigger a request here. Curl post localhost 8080 / down, right? So if we go to the browser here, the liveness probe says that it's up right now. Hit enter, and now it's down, right? So you can easily toggle this state based on events in your application code. You don't actually have to interact with the API directly. You can just use these events to publish from one component to another in the context. So now what happens when my service is down, right? Well, eventually the Kubernetes load balancer is going to do enough checks on your service, and it's going to see that your service is not responding to traffic, and the health check says it's down. So now the Kubernetes load balancer will take it out of the rotation. The question is, does it kill it immediately? Does it kill the pod immediately? Or does it give it time to finish its work? And you can configure a grace period. And that grace period is the time after which it's taken out of the load balancer, but before which the pod itself is killed, right? Before all the processes are destroyed. And you can tell Spring Boot to take advantage of that by using a shutdown period, right? So shutdown type is graceful, and this will give you a default time. So it'll stop accepting new requests, but it'll then allow any existing work to finish, right? So you can configure how long that takes as well. Timeout per phase, and it's 30 seconds by default. So you can configure it to match what you're doing in Kubernetes itself. But either way, this gives you time to let any in-flight transactions finish before the pod gets destroyed. Okay. So now I've got my application, and I want to deploy this to production. Obviously, that means I want to have a container somewhere. So I can use something like build packs, right? Paketo is a build pack project from the Cloud Native Computing Foundation. And the idea is that it's designed to take code, a Java application, a PHP application, a Ruby and Rails application, a Python application, .NET, whatever, anything, there's dozens and dozens of build packs out there for different languages and runtimes and so on. And it'll automatically inspect it. And if it's a Java Spring Boot application or a public static void main jar application, it'll inspect that jar and it'll download a JDK so that you can containerize the application and run it. And so you can do that pretty easily. You just do maven Spring Boot :build -image. And this is actually going to use Paketo, right? Paketo is a library. It's a command line application. You can download this in your CI environment for your React or Vue or whatever applications. You can use the CLI. You can say pack space build space period, and then period is the directory where your source code is, and it'll automatically create a file system that has everything that's required to run that application. Well, if you point it to a jar, it'll create a file system that has the JDK and everything else. This is great, but we also have this built into the Spring Boot Maven plugin. We're using build packs behind the scenes here. So you can see the Spring Boot Maven plugin is using Paketo, right? It's downloading the Paketo build pack for Java, downloading from blah, 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 Bellsoft, JRE, Linux, AMD, whatever. So you can see it's doing all the stuff that we would do. It's downloading all the build packs for Spring Boot, and it's going to create a container for us automatically. So no Docker files. You can do Docker files if you want, but we're happy to do it for you using this very convenient thing. And this will even do, it'll also automatically figure out how much memory you've got, how much, what's the right memory pools for your application, that kind of stuff. So you can do some very interesting things there. Now, I like this approach, but it does take a little while. So you wouldn't do this on every single rebuild. You do this in your CI environment. That'd be more natural. It'll create a container. You can then tag that container and then publish it to your container repository. VMware Harbor, GitHub packages, Docker Hub, Google Container Registry, whatever. Right? There's all sorts of different options out there. Now, I'm using a regular Spring Boot application inside of a container. You can see that this image is here, right? Docker run, blah, 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 and then it starts up, and there's my application, and it's all inside of a container, and there's my data, okay? No problem. The problem is, this is a JVM application. JVM applications take memory. So one way we can get around that is to use a native image. Native images are a very efficient way to compress the memory footprint of your application. They also start up very quickly, but much more importantly for most of us, I think, is the memory savings. Instead of taking hundreds of megabytes of RAM, like most JVM applications, these take tens of megabytes of RAM. So what we're going to do is we're going to use the build pack support for native images. And in order to do that, we have to use the Spring GraalVM native project. So Spring GraalVM native, okay, one here. Okay, so here you go, Spring GraalVM native. This project is experimental. It's not yet done, but it's very easy to use. So the idea is that you add the Spring GraalVM feature to your code base. So I'm going to do that as well. So github.com/long webflux actuator GraalVM. Here's a sample application that I always refer to. And you need to make sure you're using Spring Boot 2.4 or later. And then you need the Spring GraalVM project. Right now we can use Spring GraalVM 0.83, right? So go to pom.xml here, 0.83. And then we need the repositories, right? We need the snapshot or experimental milestone repositories. So there's this. I also like to bring in everything just to be sure. So let's go ahead and get all of this. Good. Okay. And then the other thing that we need to do in our code to make this happen for now is proxy bean methods equals false. Okay. So there we go. There's all we need to do. Now we can turn this into a native image. In order to do that, I will go to my command line, maven. Which where are we in? pwd download customers, maven Spring Boot and build -image. Now we have to do one more thing. We have to configure that Maven plugin to support native image generation. And we can do that just by copying and pasting this configuration here, right? The Spring Boot Maven plugin. So pom.xml, here we go. Spring Boot Maven plugin. Good. All right, there we go. So there's my native image support, right? I wonder what this is doing. Excludes that. That's interesting. Okay, so here we go. Actually, let's do it over here. So that'll take a lot longer. The first one takes a minute, to create the Docker image, but this is going to download all of GraalVM and run the entire build inside of a Docker container, and then it has to compile. Now, GraalVM's native image support is slow. It creates a closed world view of your service, and then it creates an application for you based on that. It takes a long time. It takes minutes, several minutes, 5, 6, 7 minutes. So we're just going to let that go, and we'll move on while it's doing its work in the background there. Now, we have our native image, we have our application, we have our service. I want to build another service. So let's go back to start.spring.io. And here, we're going to build another service, and this one's going to be called the order service. But we're not going to use HTTP. We'll use RSocket. We're going to use the RSocket support. We're going to use the config client. We're going to use Eureka Service Registration and Discovery. We're going to use RabbitMQ for Spring Cloud Stream. Right? So we have all these different dependencies to make working with our other services easier, but what we really care about here is RSocket, okay? And this is going to be called the order service. We'll hit generate. CD downloads UAO orders.zip. And what we're going to do here is we're going to use a different protocol rather than using HTTP, which has limitations because it's a very simple protocol that does request response. And if you're using HTTP 1.0 or 1.x, it is only text, or it's very inefficient. We're going to use something called RSocket. Now, RSocket is a reactive network protocol. Remember, HTTP doesn't understand true reactivity. It doesn't understand back pressure. So imagine you've got a reactive, imagine you have a network client like curl or something like that. Anything, right? Any HTTP client. That HTTP client connects to our HTTP service, and the HTTP service, if the HTTP service senses that the client has disconnected, our reactive HTTP service can cancel the stream that's being used to produce the response for that client. But that's it. We can only cancel. We can't just not do anything. Wouldn't it be nice if we could just request 10 records and then the client disconnects and we say, oh, okay, never mind. But we're not done. We're not disconnecting. We understand the state. We understand that we've already gone and done 10 records. Wouldn't it be nice if we could resume later on? With HTTP, you can't do that because the protocol itself doesn't understand reactive programming. RSocket does. It's also bidirectional. So once either side connects to the other, once either side connects to the other, the request and the response can come from either side. So there's not really a client service dynamic, right? Once two sockets connect, once two RSocket services connect to each other, then they stay connected for the life of the application, and they can send as many requests as they want at any time they want in either side, right? So it's very, very convenient in that way. So in order to take advantage of that support in our code, we need to use the RSocket server. So I'm going to tell it to start up a server on port 8181. And we're going to create an RSocket controller. Okay, so controller. I'm going to create an order service for ordered data. So we saw last time was a customer controller, and this time it's going to be orders. Now this is, the question is this a bounded context? And I would say yes, because my order data will live even after we have tombstoned the customer data, right? So public integer ID, private string name, private. Okay, but typed in the right thing twice and it didn't do what I wanted. Good, so there's this. And of course, getters and setters and all that. And I could create a repository and all that, but you know what? Let's just make it simpler. I'm just going to create an in-memory list of data. So we're going to say post construct void begin, and I'm going to create an in-memory database, private final map of integer to a collection of order, or just going to call it db new concurrent hash map. Good. What? Okay, and there we go. There's my database. Now, I'm going to write some data to the database. So I'll say, okay, for var customer ID equals 1, less than 8, customer ID plus plus, right? So I'm going to add some data for each customer. I'm going to add a random collection of databases, of orders, right? So var orders equals new array list of order, or var order ID equals 1, order ID is less than or equal to math.random times whatever, 100, right? We want some number there. Order ID plus plus. And we're just going to say orders.add new order. And it'll be the customer ID first, right? Isn't that right? Want the customer ID and then the order ID. So the order ID, rather, and then the customer ID. That's right. So maybe it's the other way around. So it's going to be order ID and then the customer ID. Okay. So there's that. And now for each one of those, we'll just write it to the database. We'll say this.bb.put customer ID orders. Okay. So I'm just synthesizing some fake data for each record. So we have something that our controller can serve up. Now, when the controller gets invoked, that's this thing right here, we will invoke it through an endpoint that we describe using message mapping. So it'll be orders, customer ID, publisher of order, get, right? So I'll say this.bb.get, destination variable, integer, customer ID, customer ID. That'll give us a list of orders. Should probably do get or default, right? Something like that. But okay, so that's simple enough. We can use is it just trying to say I should? Yeah, okay, whatever. Collections.empty list, is that gonna be okay? Sometimes you gotta argue with your IDE. All right, so there's it. So now I've got my reactive stream, and I want to say I want to create a stream from that collection, like so, and I'll return that. Okay, so orders.customer ID, and there's the entire thing. That's my entire RSocket controller, and I can now start this up. So let's go ahead and run it, and we could test this. We're going to test this by having a client that talks to it in a reactive fashion. But we can also use a nice command line utility called RSC. RSC is kind of like curl for RSocket. This protocol, by the way, was built by engineers at Facebook and at Netflix to solve some of the limitations of HTTP and gRPC and things like that, right? So it's designed to be very, very flexible. Okay, we're going to support stream, right? So stream. We're going to support the stream is the message exchange pattern. We can do fire and forget, request response, request one thing, get multiple values back. That's called stream. Send multiple things in and get multiple things back. That's called channel. And the endpoint, the route, is called orders, and we're going to provide a customer ID. Let's say 3, and that's it, right? So I'm going to make that call and I get that data back. So if I do that to this one, whatever, I get these different sets of data, right? So you can see, pretty trivial. Okay. There's our data. Now, we have an RSocket endpoint. It's working. You can encode the data however you want. It doesn't have to be Google Protocol bus. You can use Message Pack or Avro or Thrift or whatever, right? We use something called CBOR with it, which is the Jackson. Oh, it doesn't have the dependency. Oh, right, that's fair. That's fine. Ignore this for now. I forgot to comment out some dependencies. So we have our service. I want these things. I want to be able to talk to these two different things. But first of all, I want to simplify things, because notice I've got configuration here, and I've got configuration here, right, in my customer's endpoint, and this configuration is not centralized. So if I want to change any of it, I have to modify each application and then redeploy it. That's tedious. So we have something called the Spring Cloud Config Server, which allows us to externalize the configuration. You can do so by going to start.spring.io, and we're going to create a new service called configuration. And the service is just going to have one thing, config server. Okay. Sorry, give me 1 second. Okay, so we're going to create a new config server. We're going to hit generate, and that config server is just going to centralize our configuration for us. So it's going to talk to a Git repository that has all the configuration for all of our different microservices. That configuration can be version controlled, it can be secured, it can be authenticated, and so on. And then you can refresh the configuration. And for our purposes, it'll just make it easier for me to scale up by adding new services to the system, because I can have them all get their configuration from this one single place. So if I want to change things for all my applications, I can do that very easily by going to the Git repository and changing it, right? So at enable config server, I'm going to tell it to get the configuration, get URI terminal. Okay, so we're going to point it to a Git repository. Sorry about that, my friends. My partner is at the store, and I need to answer some questions when the boss says something. So here we go. We get the configuration. We point it to that. We're going to say we're going to start up on a certain port, so 8888, and that'll do. That's it. That's the entire thing. So we can now restart this application. By the way, how's our build doing? Oh, hey, this finished. Our native image, by the way, here it is. Docker run. There we go. There's our application. Starts up in 1/10 of a second, 0.12 seconds. There's our data in the database. You know, works just fine. It's inside of a Docker images already. So now you can tag that and deploy that to production, right? So hopefully that's, you know, hopefully you can see the potential there. It's a really, really interesting opportunity. Yeah, Control C that though. Okay, now, so there's our configuration server. We can test it by going to localhost 8888, and we can go to the customer's configuration for the customer service with the default profile. Oh, I forgot to do one other thing, friends. You also have to tell it which default label you want, right? So it used to be that if you created a new repository on GitHub, the default branch would be master. They've changed that for some very good reasons, but we have to remember to tell Spring Cloud Config Server to use the new default branch, which is called main. Okay. Now, if I do that, it's going to look in the main branch, customers, default, and here's the configuration. You can see there's a Git repository. It's pointing it to the Git repository to this config file, and it's got this configuration. So my microservice now in the customer's endpoint will start up on port 8082, right? So let's go back to the customer service and connect it to the config server. So first of all, get rid of all that. Go here. Let's bring back in the Spring Cloud config client, right? Good. Okay. Maven reload project. We can go here now, and we say Spring application name equals customers, and we need to tell it where to get the configuration. In Spring, we have this thing called we have this pluggable configuration mechanism. So you can see I can import configuration from class path files, from file system files, and from config trees. Now, config trees, by the way, this is for Kubernetes. If you mount a config map, if you expose a config map as a directory, as a volume, kind of on your in your pod, then that becomes a config tree. So you can point it to that. You can say, go to the config tree that lives at home, you know, config, whatever, and it'll automatically read the configuration, where each configuration key is a file, and each value is the file contents, right? But this schema mechanism that I just showed you is very useful, right? It's new in Spring Boot 2.4. And you can also tell it to use config server, right? And so the config server is that thing I just created. And you want to use a config server. The default is localhost 8888. So I'm just showing you that so you know that it exists, but you don't have to really specify that. So really, this is all I need, right, for my application right now. Everything else, this is just extra, okay? Okay, so there's my application. Let's go ahead and restart it. If everything goes correctly, this will not be on port 880. It'll be on port 8082. Okay. So there we go. There's my application on port 8082. That's good. Let's go to the order service now over here. And instead of doing that, we'll just say orders. Okay, restart that. Go to the build. Okay. Config, there's this right here. It's working. We don't need the Eureka stuff for the moment. So we'll comment that out. Don't need the Spring Cloud Stream stuff for the moment. Actually, you know what? I'll just leave the Spring Cloud Stream stuff because I always forget to re-enable it later, and we're going to be running out of time. So compiling. Okay, there we go. So now our order service is on port 8181. You can see it's on port 8181, even though I didn't specify it here. It's getting the configuration from the config server. So now we've got that. Now let's create a client, something to talk to our different services. And here, we're going to create a gateway, okay? And we're going to use the reactive web support. We're going to use the Spring Cloud Gateway support. We're going to use RSocket support. We're going to use Lombok. We're going to use the config client. We're going to use RabbitMQ and AMQP and Spring Cloud Stream. So basically, this is going to be an edge service, okay? So let's go to the Finder. We'll get rid of the gateway, and we'll hit Generate. Okay. There's our gateway. Gateway. Good. So there's the entire application, the gateway application. Now, our gateway is going to be the first port of call. It's going to be the thing that intercepts requests coming in from the outside world. It's going to be where we handle cross-cutting kinds of concerns, things like routing and rate limiting and circuit breaking and compression and security and all that kind of stuff. So we can handle generic kinds of concerns using a project called Spring Cloud Gateway. And Spring Cloud Gateway is built on top of these reactive APIs, first of all. So it's very scalable. And the contract is very simple. Return a route locator when you are given a route locator builder, RLB, okay? Route spec. New, so here, our route spec, we are supposed to describe how requests are going to be matched in the incoming request. So we're going to say that this is going to run by talking to the Spring Cloud config server. So we say spring.application name equals gateway. Spring.config.import equals config server, colon. Okay, so it's going to talk to the gateway config server. And it's going to match incoming requests that go to the proxy endpoint. And then when those requests match, then we want to send them to some other place. And so I can send them to 8082, for example. That's the customer service, isn't it? Right over here, port 8082. So we're going to proxy them here from the gateway to the downstream service. And then I can apply filters as well. I can say filter spec dot add request handler. Sorry, set path, right? So what I want to do is I want to send it to I want to match the incoming request going to proxy, but I want to send it to the customer service going to customers. Well, the path is already proxy, so I can't have proxy / customers or customers / proxy. So I need to change it, and I can do that with a filter here, like so. I can say customers. So it's going to strip away the existing path, add a new one, and then send that to this endpoint. And these filters are where the real power of Spring Cloud Gateway is. I can do all sorts of interesting things. I can add response headers. I can say HTTP headers dot, access control allow origin asterisk, right? So I can do cores, for example. I can do rate limiting. I can say request rate limiter. I can do a retries, and I can do redirects, and all sorts of different things based on these filters if the downstream service isn't working, right? So very, very flexible way to describe cross-cutting kinds of concerns. So let's run this and see what we get. Good. So there we go. There's our gateway code. It's up and running. Localhost. Which host and port? 9999. So proxy. And when I call that downstream service, even though I'm calling proxy, it's immediately giving me the data from the downstream microservice called customer. So I'm getting the customer's data. Now, I didn't have to write this Java code, actually. I could have just used the configuration. This Java code is just an example of the Java API, but there's some interesting things that you can do with no code at all. So for example, if I look at the property file here for the gateway, you can see I've got this thing called the discovery locator. So if I was using my Spring Cloud Discovery client with Netflix Eureka, this would automatically set up a gateway route for every single service in my service registry. There's lots of use cases for service registration and discovery, one of which is easy discovery for things like gateways, but also because I can use it for certain patterns, right, that we're going to see in a second. Where DNS is not very flexible, service registration and discovery can be very useful. Now, we have our gateway. Spring Cloud Gateway is awesome. People use Spring Cloud Gateway as an ingress controller. You can actually swap out the ingress controller inside of a Kubernetes cluster. And so if you wanted to, you could actually set up TLS or SSL for just your Spring Cloud Gateway ingress controller, and then have this be the proxy through which everything flows, right? It's the thing that does the routing to other services in your Kubernetes cluster. It's a very natural kind of arrangement. You can also use this as a Cloud Foundry route service, which is the same idea. It's a service that gets invoked right after the request has entered the cluster, but before it has been sent to the target virtual machine or target application instance. So I have my Spring Cloud Gateway application. This is great for generic kinds of transformations, right? I don't know about the kind of data that's coming across. I don't look at the actual JSON and go, okay, I want this and that. I'm not doing anything specific. I'm just applying general rules to the payload. It doesn't matter what payload, right? But if you want to act on the data, and this is very common, right? Especially if you have different kinds of clients, your iPhones, your PlayStations, your Xboxes, your iPads, your Android devices, all of them have their own client-specific use cases for security, for compression, for payloads, for whatever. So it's very natural to create an endpoint that has a view, a materialized view of data for your clients to use. So rather than having the slow Android client on the 3G speeds out in the middle of the mountains, rather than having it call service A and service B and then merge them together in memory in the client, you could just do it on the server much faster because you have high speed, and then you can send a lighter, more compressed, ready-to-use payload back to the client, right? So very, very natural use case. And this requires scatter, gather, sort of service orchestration and composition. Here, reactive programming can be really helpful. So let's create a CRM client. And our CRM client is going to have a view to give us all the orders for a customer. So, turn. Okay, there we go. Wrong order. Okay, I want to have the orders, and I want to also have an endpoint that gives me all of the customers, right? Get the customers. So you can see I've got a problem here. I don't have these types on the class path, so I need to do something terrible, something that you should never ever do ever, not even when you're all by yourself at home and no one is looking. I am going to copy and paste code. So I'll go back to this customers endpoint, and I'll copy and paste the customer object. Okay, voila. Customers. So we go to the gateway code here. Got that. And we want to get the order object as well. So go back to the orders object. Order. Okay, paste this as well. There we go. So there's my order and my customer. And now I've got my client. And so in order to make that network call, why is it giving me public? I don't want public. Private final web client in order to make that network call, I'm going to use a reactive non-blocking HTTP client, okay? And that reactive non-blocking HTTP client is called the web client. And it's you can use it with non-reactive HTTP services. It's awesome. I would definitely use the web client from now on, right? It's one of those things where it's just way better than the alternative. So here's how you build an instance of it. Right, just there you go. That's my reactive non-blocking HTTP client. And I can use that here to call the customer service. So we'll say this.http.getURI HTTP localhost 8081, did we say? What did we say? Customers 8082, okay? So gateway, good. /customers. So the data that's going to come back is going to be JSON. I'm going to turn it into a JSON stream of customers. There's my stream, right? The reactive stream of customers, like that. And now I want to make sure that if something goes wrong, that I get the data. Right? So this is going to make a network call. But what if something fails? What if the service isn't available? Well, I can then say I want to do a retry. I want to retry 10 times. I want to retry 10 times, but with a back off. So I can say retry back off 10 duration of seconds, right? I can do error handling. I can say when there's an error, resume exception flux.mt. I can degrade gracefully. I can do a timeout, right? Timeouts are a natural thing. You can do that as well. Although I would say timeouts aren't necessarily the best way to solve this problem. The reason that most people use timeouts is because, and by the way, I separated these so you could see what's happening, but you can do this too, right? You don't have to have a separate variable. So the reason that most people use timeouts is because they're trying to make sure that they get a response within a certain window of time so that if something goes wrong, they can retry, right? So the timeout is a way to retry the request with enough time to try again. So let's say that you are at the edge service, you're a gateway node, and you've got 20 seconds of time. That's a huge amount of time. It's an eternity of time. But you've got 20 seconds to produce a response. But you must call the customer service. The customer service then has to finish in 10 seconds, right? Because if it fails, if you can't get a request, if the service isn't available, if there's a timeout, if the garbage collecting is happening, or whatever, then you want to make sure that you fail quickly, stop it at 10 seconds, and then try again within the 20-second budget that you have for your request. Okay, what about the customer service? Now we're no longer at the gateway. Now we're at the customer service. Now the customer service has how long? Well, it has 10 seconds total, but it has to call, let's say, it has to call some other service. So now it has to call that service within 5 seconds, and that thing must produce a response within 5 seconds, or the customer service will try again so that it can get 2 attempts within 10 seconds. What about if the customer service depends on another service, right? Well, now that service has 2.5 seconds. Do you see the problem here? Right? 2.5 seconds is a long time. 20 seconds is insane. But most of us don't have 20 seconds. That's a lifetime, right? That's an eternity. Most of our requests are milliseconds, not seconds, right? They should be anyway. And so we can't squeeze more and more time out of each subsequent hop in the journey just because they're further away from the origin of the request. So we want to make sure, sorry, the heater. We want to make sure that we get a response back, but if we use timeouts, we only have 2 attempts. I want to, first of all, have more attempts, and second of all, I want to make sure that if something goes wrong, I get the response back too, right? So I want the benefits of timeouts, but I also want more opportunities. So there are other patterns that we can use. One of them is called hedging. Hedging just means, in English you say, I'm going to hedge my bet. I'm not going to put all of my money on the casino table on one color, for example, not just on red. I might put it a little bit on black, a little bit on red. That way, if I lose here, I might still make money there, right? Or something like that. Or in the stock market, you don't put all of your money in one stock. You buy some stock here, some stock there, some stock there. And that way, if something goes wrong here, that's okay because you've put money there, right? So there's lots of different things that you can do here to hedge your bet. Hedging is very useful in a distributed systems architecture as well because this service might be slow. It might be garbage collecting. It may not work. So we want to make sure that if it fails, we can do the right thing. And the way you can use hedging is you launch, let's say, 3 calls. You make the same request 3 times. You call your service registry and you ask the service registry for 3 different hosts and ports where you can find the same service. So you've got a cluster of 10 instances of the same exact microservice, and you want to make a call to each one of them. Well, with hedging, let's say I'm going to call host 1, host 2, and host 3. So this is to do, right? The null here, you replace that with this, right? But you change the host and the port. So you have different hosts and ports. Now I've got 3 different pipelines. I want to launch all 3 of them at the same time, exactly the same time. And then whichever one produces a response first, I keep that one. And then I apply back pressure to throw away the other 2. Very useful, right? So I can say flux.first, okay? Host 1, host 2, host 3. Okay, so that's my hedging example. So it'll apply back pressure. It'll call all 3, launch them at the same time concurrently on different threads, and whichever one produces the fastest response, we keep that one, and that's what's stored in this variable in the return value. But the other 2 automatically have back pressure applied to them so that they're not wasting time producing a response that nobody will need. So this is a good pattern because it guarantees that we have 3 different shots, 3 different attempts. It doesn't have to be 3, by the way. It could be 4, it could be 5. It's really up to you, right? It's arbitrary, right? So I could do 4, right? The tool doesn't care, right? So either way, you have a lot of flexibility. Now, of course, this only works on the endpoints where you're going to call and you have the ability to make the call multiple times. So don't use this for the charge the customer credit card endpoint, right? That's not a good idea. You should use this for read-only or idempotent endpoints. So hedging is a very natural pattern in the reactive world, but it's very difficult to do without reactive code. Imagine this code with threads and executors and runnables and countdown latches and cyclic barriers and whatever. It'd be very hard code to write. Remember, only one person truly understands how to write multi-threaded Java code. And it's not you. It's not me either. I don't know who it is. The point is we shouldn't have to figure that out ourselves. There's a lot of risk and no reward. Use the reactive APIs to do this work instead. So now I've got my hedging, I've got my customers endpoint, I've got my orders endpoint. Orders is going to be an RSocket endpoint. So we're going to use the non-blocking RSocket client instead. So private final RSocket requester. Okay. And the RSocket requester, I also have to create an instance of. I say bean RSocket requester dot builder. And remember, when you with RSocket, the microservices connect at startup time and they stay connected, right? So here I'm going to connect to the RSocket service, the order service. This is running on port 8181. And so now I want to use the RSocket client in my gateway code as well. So I have it here, RSocket requester. Just get rid of this. There you go. And we say RSocket route orders. I'm going to pass in a parameter there, customer ID dot retrieve flux order dot class, right? And we can use the same operators. This is just a reactive stream, so we can do retry and we can do all these things, right? It's the same exact API, same exact primitives for making sure our services are more robust. So now I've got the order service and the customer service. The last thing I want to show you is how to create a materialized view out of this data. Well, one of the last things I want to show you. So let's suppose I want to aggregate the data from these 2 different sources and sinks. So I create a new class called customer orders. And this is going to have, why is it always public? This is a new thing I don't like at all very much. Private list of orders, okay? Good. So there's this. And we're going to say at all args, no args, etc. Good. So there's my reactive stream, my aggregate type. And I'm going to create a new view of the data. Customer orders, get customer orders. Turn. And what I'm going to do is I'm going to say for each customer, I want to map over the data. For each customer, I want to map over the data and get the orders. So I need to store in memory the customer and the orders for that customer. So what I'm going to do is I'm going to create a tuple. A tuple is a typed object with named slots. So parameter 1, parameter 2, parameter 3. I mean, each one of which has a generic type. So I can say flux.zip, and here I'll create a mono out of the customer, right? And then for the second parameter, I'll get the orders. I'll say get orders for customer.getID. I'm going to keep all of that as a list in memory, okay? So what do I have now? I have here our results. You can see I have a flux of tuple of customer of list of order. So I'm almost there. I need to take that tuple and turn it into a customer object, a customer record orders. So I can say results.map tuple new customer orders tuple.get T1 tuple.get T2. Okay, there's my reactive stream. I'm saying publisher of custom orders, and it's automatically doing that for me. It's just very easy to read. So I'm making 2 different network calls across the internet. I'm getting the result of 2 different microservices. I'm composing them at the same time. So I'm making as many concurrent calls as I can, and I'm very elegantly taking the data from these different streams. One is HTTP, one is RSocket, but it doesn't matter to me because they're both just reactive streams, and I'm composing them in this natural way. This is really, really nice. It's also very efficient. Remember, this is an N+1 problem. I'm making 1 call for all the customers, and then I'm making N calls for each of the orders for the customers, right? For each of the customers, I'm getting all the orders. So this is not an ideal solution, right? Ideally, you would not have N+1. Ideally, you would have like 2 calls, 1 for all the customers, and then 1 for all the orders for all the customers that were returned in the first query, right? And if you can design your schema that way, that's even better. But at least in this case, even though it's not desirable, at least it's making the calls to the different orders calls concurrently, right? It's getting the orders for customer 1 and customer 5 and customer 9, whatever, all at the same time, as much as it can, given our ability to create new threads and so on. So very, very, very fast. So let's go ahead and try this out. Let's see what this looks like in action. I want to create an endpoint up here, and we can create a new gateway endpoint using the functional reactive style, right? I've showed you the REST controller style, HTTP endpoints. I'll say return route good build get customers, or just we're going to call this customer orders. Okay. Return server response. Okay. Body. And what I want to do is I want to use the CRM client that we built to make a call to the downstream service. I'll say, give me all the customer orders. There's that. And I'll just return customer orders.class. Okay, so there's this. There's that. So that's my network call. Let's go ahead and start this up and see what we get. This is another way to create HTTP endpoints. You can use the Spring MVC style, controller style, or this, or you can use both in the same application. So localhost 9999 COs. What did I do wrong? Oh, there's something already running, of course. Sorry. Okay, there's our data. So we have each customer and all the orders for that customer all at once. Very, very quick, right? I can do this all day and I get responses. So, my friends, how much time do we have? Do we have to stop here, or can we do 10 more minutes? I'm happy to stop here if we need to, but if not, I'd like to show you messaging. Can you give me some indication if that's okay? Anybody? Okay, I'm going to assume it's okay. Nobody is saying anything that I can hear. We're going to go a little bit longer here. I know it's supposed to be 90 minutes, but my calendar said 2 hours. And I've got to show you one last thing, because so far we've been reading data reactively. We've been using the reactive APIs to call these different microservices to get the response, to create a view of the data for the consumers of the data. But what if we want to update the data? We want to change it, right? And in this case, we should not try and use distributed transactions, right? Distributed transactions make no sense in the world of microservices. Instead, we need to make sure we use something like the tell, don't ask pattern. The tell, don't ask pattern is very simple. You tell microservices about the changes in the world, and they create their own view of that data based on those changes. They update their own local view of the state of the world. Remember, microservices don't share one giant ERD diagram. They all have their own database model, their own schema, their own domain. And they communicate through a network API, not through the backend database, right? So they're not sharing that information anyway. So what I want is, if I'm the order service, I care about orders. I care about which requests have come in for products, and I care about available inventory in the catalog. I care about that kind of stuff. And I care about customer, or maybe that's the fulfillment service. Maybe the order service is the one that cares about credit cards and the pricing and revenue recognition and that kind of stuff. And then maybe the search engine service cares about keeping an Elasticsearch database to have the whole catalog of all the text and all that stuff that's searchable. And maybe the customer service cares about each customer's profile and the account, and connecting it with Facebook and Twitter and all that stuff. So there's different services. They have different databases. They don't communicate using the XOpen protocol. They're not using JTA. It wouldn't make any sense even if they did, right? Because MongoDB doesn't speak XOpen. HTTP doesn't speak XOpen, right? So these things have their own domain model, and they're not the same kind of domain either, right? Elasticsearch is not the same as MongoDB, is not the same as Neo4j, is not the same as Postgres, etc. So what I want is, I want each one to change the things that matter about them based on events. So I want to say to this, I'm going to send a message to the gateway. I'll send a message to delete data. I want to delete customer data. And what does that mean? Well, of course, in the customer service, it means to delete the record from the database, right? In the orders endpoint, it means I need to delete all the orders for that customer ID, right? So either way, I have work to do on both sides. And I'm going to send a message, an HTTP delete command to the customer's gateway, to the CO's gateway, and then that'll publish a message using Spring Cloud Stream to both microservices, to all the microservices in the cluster, and each one of them will get the message, and they'll say, oh, okay, for me, that means I have to do this. For me, I have to do that, right? And eventually the world will have an eventually consistent view of the data that says that this customer no longer exists. And the best part about that is that it's scalable. I can send messages all day long, right? And it won't get lost, even if the service that I'm trying to make the change with isn't available right now, right? So we can do this pretty easily using Spring Cloud Stream. Spring Cloud Stream talks to RabbitMQ or Apache Kafka or Google Cloud Pub Sub or Azure Service Bus or Redis Streams or whatever, right? I've got the RabbitMQ Spring Cloud Stream binder, and I've got the RabbitMQ support there. So I've got Spring Cloud Stream and I've got RabbitMQ. I want to write code here that sends a stream of IDs to delete, okay? So this is going to be, let's see here. Links.many.multicast.on. Okay, that's this. And it's going to be a stream of integers. These are the IDs of the IDs, right? So customer to delete, okay? Or customer deletions. And now I'm going to create a Spring Cloud Stream component. Now, the nice thing about Spring Cloud Stream is that it uses the Spring Cloud Function programming model. And Spring Cloud Function uses just regular Java util function, Java util supplier, Java util consumer, these kinds of types, right, to describe its endpoints. So that way, this is very easy to unit test. You can also use Spring Cloud Function along with Spring Cloud Function adapters, and these adapters will allow you to write functions that work with AWS Lambda or Google Cloud Functions or Azure Functions or whatever. these different kinds of functions all have the same programming model now if you use Spring Cloud function. So let's create a bean here. Whoops. And we're going to produce a supplier. It's going to produce a supplier of integer, deletions supplier, and return a new supplier here. Okay. And we're going to return customer deletions dot as flux lambda. The reference, there's this. So that's the entire programming model. So when somebody puts this is a processor, by the way, when somebody puts in a message into this thing, it's going to be sent as a result out of the supplier to RabbitMQ, which will then broadcast it to all the consumers for RabbitMQ. So now I want to update my code down here to create a new endpoint to do deletions. So we'll say CO's customer ID, new handler function, server response, .ok.body, and the data will be path variable customer ID. Okay, so there's the customer ID. I'm going to turn this into an integer, .parse int, and I'll send that into the results. I'll say, okay, customer deletions, try to emit this value, customer ID, and is it a success? Success. Okay. We're gonna send that in. We're gonna say, okay, success is the value that we're gonna send back in the response. So we're gonna try and we're gonna emit a ID into this reactive stream. That's gonna be sent to RabbitMQ, and then the RabbitMQ will then federate that out to all the microservices that care about it. So I've named this endpoint deletions supplier, but I have it in my configuration. You have to tell Spring Cloud. You have to have a configuration to tell it what to name it. So I'm going to go here. We're going to call the gateway endpoint, and the gateway endpoint is called customer deletion supplier. So there's that. So that's my gateway code. Now on the consumer side, let's just do one of them because it's the same for both, right? We're going to go to the customers endpoint here, and we're going to create a consumer that consumes the data instead of a supplier that produces the data. So we'll go back to here, customers, and the definition will be customer deletions consumer. Okay, and we're going to go to customers. Yep, customer. So it's going to be a consumer of publisher of integer. And this is just going to be a callback that gets registered to listen for messages from this reactive stream. Actually, we're going to be given a reactive stream when the application starts up. And we're just going to process each new message, customer IDs. Right? So customer IDs dot flat map customer ID. I'm going to use the customer repository just like before, customer repository, CR. Say cr.delete by ID, customer ID. And that's it. We can subscribe there, right? We just subscribe to the reactive stream. I'm going to also log out each result. I'll say do on next CID deleting customer ID. Good. There's our reactive stream. Okay, so with a lambda. Okay, so there's the entire thing. Okay, good. Now we can start this up, and whenever a new message gets published by RabbitMQ, it'll be consumed here, and then we'll log out the print, and then we'll log out the fact that we're going to delete it. Then we're going to actually delete it, and then we're just going to subscribe to the whole thing. So this will just keep running for as long as the application's up. I forgot to bring in the dependency there. I do this a lot. I often forget this. I'm getting better though. So bringing that in. We don't need this. We do need these two though. So let's bring that in. Okay. So if you try this and you don't know why it's not working, make sure you bring in the dependencies, because look, it's just a Java util function. It's not invalid, even though there's no dependency, right? The Java util function types are on the class path. It's the one thing. It's like, oh, got to remember to bring in the right dependencies there. Okay, so what happened here? Oh, table customer already exists. Okay, that's fine. Why are we? Sure, whatever. Who cares? Okay, so we've got that. Now, let's see. Let's go to our endpoint here. There's the data. I want to delete the data for 1, right? So I'll say curl -x delete HTTP localhost 9999 COs 1. There we go. It's gone, right? So ID. We see it for the orders, but we don't see any customers with ID 1. And here's ID 2 for Martin. I forget. So 2. No more Martin, sadly. I miss him already, right? So you can see now I've got this very, very easy API, very seamless to integrate different messaging backends or serverless platforms, right? It's the same. It's literally the same API. I could write the same exact code exactly like that, and instead of getting messages from RouteMQ, it could be a serverless function that is being invoked. This could be an AWS Lambda, right? This consumer. So really, really powerful. I hope you've got a sense for what's possible. We've just looked at a few things today, my friends. We looked at building reactive APIs. We talked about building cloud native services. We looked at what motivates these technologies. We've looked at using core reactor and the core APIs. We looked at data access using R2DBC. You can also use reactive NoSQL options like Elasticsearch, Azure Cosmos DB, Google Cloud Spanner, Redis, MongoDB, Cassandra, everything, right? Elasticsearch, all these different things. We also looked at building functional, reactive, and REST controller style MVC endpoints or WebFlex endpoints. We looked at how to use the actuator to make it easier to integrate with our platform, how to set up health and readiness probes and liveness probes. We looked at how to change those probes. We looked briefly at the integration with Micrometer. We then looked at what happens when your service needs to be deployed to production. We can use build packs to containerize the application, and we can use build packs to create native image applications, and we can deploy those to production in Kubernetes. We looked at graceful shutdown. We then looked at RSocket and looked at how to create an RSocket endpoint. We looked at then Spring Cloud Gateway. We looked at Spring Cloud Config Server. We looked at centralized configuration with a Spring Cloud Config Server. We looked at client-side service orchestration and composition using reactive APIs. We looked at the tools that you can use to make reactive APIs more robust. We looked at patterns like hedging, and we looked at things like retry and on-error resume and so on. And we talked about back pressure. We talked about using Spring Cloud Stream for messaging and for PubSub and the tell, don't ask pattern. We looked at a lot of stuff, my friends, but we've only just begun, right? You can see here, there's a lot of interesting opportunities right now, and I hope you'll give it a shot. I hope you give all this stuff a look. Everything we've looked at today is reactive, right? We looked at reactive APIs all the way through. So you can see that's a very important part of this larger discussion of how to build services that are destined for production. And I hope you enjoyed what we're looking at. I hope you enjoyed what you're seeing. Obviously, you don't have to take my word for it. I'm wearing the Spring t-shirt and the Spring underwear. Of course, I'm a big fan, but there's other organizations out there, right? So I talk about Netflix and Alibaba and all these large organizations, eBay. These organizations have the money and the motivation and the need to solve these problems, and yet they still choose to build on the Spring ecosystem, to build on the VMware Tanzu ecosystem, because it allows them to build better software faster. And at the end of the day, that's really all that matters. Thank you so much for your time, my friends. I want to wish you a happy holidays, and I hope you're healthy and safe. And I hope next time that we can hang out together, safely and healthfully, together in beautiful Warsaw. Thank you so much for having me today, Dziękuję. I appreciate it very much.
Yeah, thank you very much, Josh. Thank you very much for being here. And I hope next time we will be able to meet in person in Warsaw. So first and first, we have a question from Josh himself. So if you were paying attention, you probably will able to answer on the chat. I just displayed the question on our video. So there will be either a book from the Certo or IntelliJ license, what you prefer. So while you will be thinking about the proper answer, I'll look on the comments because there were quite a few discussions on our chat, basing on your presentation, Josh.
Wonderful. Where is the
yeah? There is a comments section on the right.
Oh, can I see it?
So
Okay.
yeah.
Oh wow.
So you have everything that that's coming from YouTube, and yeah, can see that some of the questions were answered. Thank you, Michał Rowicki. Thank you, Jakub Nabdalik, for clearing some things up. So those we will not discuss because there were discussion themselves. But our first question, I think, that was not answered is this one: how to add a Victor for an active socket in React or Netty? As far as I know, it's impossible. It would be very handy for every AWS environment, as an active connection behind NAT receives TCP reset after 356 seconds of inactivity. And Michał asks if you know any workaround for that.
No, I don't know much of anything, but I do have my email, josh@joshlang.com. Send me an email and I'll connect you with the Reactor Netty team, and they will, they know more than I do. They can help. They're very nice.
Okay. So Michał, or everybody that will follow, if that will be the case, please do what just.
I don't know the no.
Michał was very active today. So next question, David.
So next question is, could you describe?
Oh, sorry.
Sorry.
Sorry. There is a banner coming on. Yeah. Come on. Are you clicking? Okay.
Yeah. So could you describe mono, that materialize method?
Me either. Let me see. Mono materialize. This is the fun thing. Okay, dematerialize. That's not what we want. We want materialize. Here we go. So what does this do? Download source. I'm learning just like you. There's so many different operators. Transform incoming into signal instances. Materialize, since the error is materialized as a signal, the propagation will be stopped and oncomplete will be emitted. Complete signal will first emit a signal complete and then effectively complete the flux. No idea. Yeah, I don't know. This is mono materialize. Let's just see what it looks like.
Okay, so yeah.
So
you can go to the next question.
Language.
Come on. I'm looking for the next question that was not yet answered on our chat. David, if you see anything. Okay, another one from Michał. As I said, he is very active today. Could you tell us how to use Reactor's context, as we can't use thread locals?
Finally,
something.
So
perfect.
The context is a dictionary-like object that you have access to inside of your reactive pipelines, and you can create a new reactive stream by saying, flux.just. And then you can say subscriber context. So when you create the reactive stream, you can assign a context object to it. That context object is like a dictionary, right? It has keys and values. Those keys and values will be propagated along the life of the application. Along the life of the pipeline. So from step 1 to step 2 to step 3, etc. You can access them in the do on next, or maybe it's do on each. Yeah, probably do on each from the signal object. So you can say signal.get context, and you can read that data. The benefit of that is that even though the reactive stream will move from one thread to another, you will be guaranteed that that data will be passed along. It'll be propagated. Because remember, in the reactive world, there's a number of thread locals. It makes no sense, right? You cannot guarantee that the thread on which the request has arrived will be the same as the thread on which it'll be finished when it goes out, right? So very, very useful thing. We use it internally, and you can use it. It's a public API. We expect people will want to use it, but we use it for a lot of use cases. So maybe we support transaction propagation. So for example, if you're doing resource local transactions with R2DBC for a SQL database, you want to do 2 different statements and you want them to be atomic. We make sure that can happen in a reactive context. We use it with Spring Security. So when you authenticate, a request comes in, the incoming request has a username and password. The Spring Security filter looks at the incoming request and then installs the current authenticated principal in a context and makes it available so that you don't have to re-authenticate at every single downstream layer, instead of a thread local. We also use it for distributed tracing. So if you're using Spring Cloud Sleuth, which is our distributed tracing abstraction, which by the way, the legendary Marcin Grzeziak, part of our team, is lead on, right? So that project allows you to follow the movement of request in the system. So from one node to another, to another, to another. And it propagates the trace ID and the span ID. And that information, each time there's new data added to that trace, it's emitted out of band to a distributed tracing system like Google Cloud Stackdriver Trace or Zipkin or something like that, right? So there's a nice abstraction there. And that is based on the context for reactive applications. So we use it for a lot of the common things, but people might want to use it for logging. I think this is a very common use case. They want to propagate logging context and so on. So, that kind of stuff.
Okay, so let's get to our next question from Jane. So in our project, we encountered the lack of annotation support for reactive methods. For example, integration of Spring Reactor with Micrometer. Could you recommend how to resolve it?
Integration of Spring Reactor. In our project, creating annotations around reactive methods. So I'm not sure I understand the first question, but the second question, let me just speak to that. When we have a method that returns a reactive type, we add filters to that. We use the operators. We turn that into a stream. We intercept it. So we can do flux.doOnNext or whatever. We can actually wrap it and then add something to that. So we don't, the proxy really, if we use annotations to proxy methods and all that kind of stuff, if we create a component model around reactive APIs, all we're doing is we're doing it just to get access to the reactive type that's the return value, right? Because we expect the methods are going to return a reactive stream. And remember, when you use reactive code, the time when you execute something is not the same as when you return the value. So you might return a reactive stream, but you don't actually do anything with that reactive stream for a week, right? It could just sit there in memory and until you call subscribe. So the result is that you want to intercept the reactive stream, not the method, right? That's different now. So I would just create something that captures that reactive stream, wraps it in another reactive stream, and then adds filters to it so that you can be aware of certain lifecycle methods like doOnComplete, doOnSubscribe, etc. I hope that answers your question. I'm not sure I understand it exactly. I'm not sure about the annotation.
Jane, if there is something more that you would like to ask after this question, please ask on that maybe we'll manage to ask it to Josh. Okay, Josh, if you could look up the answers on the chat, the last answers from Mateusz, for example, if they answer your question on the stream motivation for reactive programming, that would be great.
Wait,
data streams to synchronize back pressure.
Oh yes. What is this? Data streams asynchronous back pressure.
So we are waiting still. So
these are the three answers to the question that we put out there for the contest?
Yeah.
Yes.
I think so. Yeah.
It's not quite right? Should I tell you what the answer was again?
No. So maybe we'll wait another few minutes or a few seconds because we have that delay. So please. So the contest is still open, and we have the kind of trivia question from Mateusz as well. Did you know that in Poland, Kotlin refers also to a ketchup name?
I had no idea, but I love it.
So it's a very, very popular one. So that's a trivia you can use in a work and something like that.
I had no idea. And by the way, Kotlin and Reactive, really a nice combination because when you're using Kotlin, the programming language, not the ketchup, they support something called coroutines. And coroutines are, when you use reactive code, Reactive Spring with coroutines, we automatically use reactive APIs. So if you use coroutines behind the scenes, it's using reactive APIs. So you can write this very nice deterministic looking code. You can avoid the constant method chaining if that's not your style. But still behind the scenes, it'll suspend the thread and defer to these reactive APIs and so on. Very nice combination.
I think that people get scared of your question, so there is no other answers.
I'm not
I
using a
can't.
silicon-based MacBook Pro. Somebody asked me about it if I'm using that.
Yeah.
No, not using that yet. It doesn't. It wouldn't. I wouldn't use it for Java yet. It's not good. It's slow because I have to do everything in Rosetta. So.
You've been also accused of having superhuman powers when you're doing your presentation.
My
so
superpower is Spring, right? You can have the same one.
I don't think so, but I'm in contact with Marvel. They want to do a series on you on Spring bands.
Yeah, right.
We are in contact for that. Okay. Think that's everything. I can't see any other questions coming. Yeah. Before we will end, and I thank you very much. I have something from WJUG because there was no answer to your question, and we still have some prizes to give away. So there is one special Christmas word hidden here. I wrote it down. So if you go to our Slack channel, JVM Slack, on our WJUG channel, there is a place that you'll under this thread. Please guess what's the word written down here. It's a Christmassy word, and I can say also that there is one red part of that thing. So it has a red part. We have still IntelliJ licenses. We have books from the Certo. We have workshop days. So please go to our Slack channel and try to guess what's there. If we manage to find it out right now, I'll open it. Otherwise, I will open afterwards and take a picture of that so that we are not cheating, because I still can't see any answers to your question, unfortunately.
I can give people a clue if they want. Actually, one guy, Marcin, got 1/3 of it, right?
Okay, so optimization of resource use, that's one. We're still looking for 2 of them.
Yep, come on, you're close.
So everybody.
Maybe we can give people a clue. Maybe we can give a clue.
Well, there's one of them, optimization. I can give one of the other ones if you want.
Oh, come on. You've been listening to Josh for this evening.
But to be fair, if this is in the beginning of the presentation, like 5 years ago, when I started talking, and then also I screwed it up the first time, so I had to repeat it a couple times. But they might have gotten confused because I said it the wrong way in the very beginning. So we've got resource efficiency. That's one. That's what Marcin gave us. And then there's 2 others. I can give one of the other ones if you want.
We'll wait for the second one, and if there will be second one, you can give away the third one.
Okay.
Come on, guys. There's few of us here, and really nothing. We do have prizes. We do want to give it to you, but you have to give us something.
Who had fun, by the way? I'm just trying to figure out. If you had fun, just let me know. Who learned something?
Yeah.
Let me know.
Exactly. Maybe there is some problem with connection, and they just don't hear us, and that's the problem. So please answer to Josh who had fun today, and maybe that will settle it.
I appreciate that you all hung out with me today. It's an honor. It's been quite a year. I'm so glad to be able to hang out with you all.
Yeah, exactly. At least something that we can do is getting online with you, but it was quite a year, and I know that it means nothing. So the end of the year means nothing in terms of what's going on around the world, but it's symbolically hope that it will be better next year.
Me too.
Because so many things happen, so many weird and also bad things happen. So yeah, I think I hope that we just lost people because no one is answering anything and posting anything. So I just hope that we just broke, and that's why people just write to us, because that's the only explanation I can actually accept.
Yeah.
That would be pointless to wait. Josh, if you can, Marcin was the only person to actually answer 1/3. So if you can say the two missing ones.
Sure, consistent. Right, we want something to make it. We want a consistent API. That's one. Resource efficiency. That's the other one. And then reliability, right? I want a toolkit to make it easier to deal with, network failures and things like that. And reactive APIs gives me all three.
So there is a consistent way of handling different kinds of data. And it was before you said so, because we had like 10 seconds of delay. So I think Marcin and Tom T, please write us. I will post our email, leaders małpa at Warszawa.pl. Yeah, małpa is Polish for at. Please, Tom T and Marcin Vasiluk, please write to us. I'm still waiting for the answers for our mysterious word here on the Slack channel. And I think that we'll going to end this for today, because I hope that maybe everybody is in a Christmassy mood. Thank you very, very much for being with us here today, this evening, or for your this morning. And I really hope that next time we'll be able to meet in person in Warsaw also. So thank you very much. We were very happy to have you, and that for everybody, yourself included, have a Merry Christmas and very peaceful ones this year.
Can you take a selfie?
Yeah, sure.
Pretend like you're happy, okay? Just pretend. Ready? 1, 2, 3. Open source. Okay. Thank you. Get it?
Perfect. Thank you very much.
Thanks.
Thank you very much, everybody that managed to listen to us for this year. And the video will be here on the same YouTube link. So once again, thank you very much. Merry Christmas. Have a